In section 0.6, we're looking at fractional exponents. We're going to see radicals brought in, and we're going to now be able to connect radicals to just the exponents we've been looking at. It starts with x to the 1 over b. If that is our exponent, we can change that into the b root of x. So the denominator in the exponent becomes the root that it's looking at. The common one we see would be something like x to the 1/2 is the square root of x. Now, we don't typically just go with looking at the roots here. We'll add a little bit more to it. So I have x to the a over b off to the right. And what that's going to become is x, the b root of x, and then a is still the exponent, or the b root of x to the a. Either one, they mean the same thing. It's really, when you have a b in the denominator for exponent, that becomes the root. The numerator just stays as the exponent. So really on these that show up, if you look at these examples I have below, even before we're going through and solving them, the denominators are the roots you're taking. The numerators are the exponents of it. Now, we have to simplify these down going through. What I would recommend, instead of sitting there trying to break it up into different fractions, if you change it to radical form, you can usually see how to simplify it. It's going to be easier to take a root first, then do the exponent. Let's start with 27 to the 1/3. It doesn't really show it, but we'll see when that applies. So this becomes the third root of 27. Okay, we switch to radical form. Exponential form is where we started. We go to radical form. Yeah?
How come on x 1/2 it doesn't become, oh wait.
In the square root, we don't have to write the 2.
Yeah, I know that.
Yeah. Okay, so what is the cube root of 27? Perfect, 3. So 27 to the 1/3 is 3. Now, it didn't have a numerator, or the numerator was just 1. That was kind of a basic one to start. We go to 16 to the 3 over 2. We could write this as the square root of 16 to the 3rd, or the square root of 16, and then that value to the 3rd. Different things. In the top one, you're going to take 16 and cube it, a very large number, then take the square root. In the bottom one, you're going to take the square root, then cube it. It's always easier, just like reducing fractions, to get smaller numbers, then finish it. So if I did the square root of 16 to the 3rd, that's equal to 4 to the 3rd, which is how much? Perfect, 64. Change it to radical form. Simplify the root first, then go exponent. 81 to the 3/4 is going to be the fourth root of 81 to the 3rd. Do we know a fourth root of 81? So that's 3 to the 3rd becomes 27. What's that? You don't? Which part lost you? If I did the fourth root of 81, 81 is 9 times 9, which is 3 times 3, 3 times 3. So we have 4 3s there. So the fourth root of 81 becomes 3. So going back to what we did a few days ago, if I took 81, that's 4 3s. So that makes that fourth root into just being 3. Then we do the exponent. Now, what's nice about this is we start to recognize the patterns. We should know the perfect squares. The cube values we're starting to see, at least the smaller ones that show up. Even the fourth roots for like 2, 3, 4, 5, we can kind of guess our way through. If I went to 343 to the 2/3, what's that going to be? What's the cube root of 343? 7, yeah. That's a lot easier than squaring it, than taking the cube root. We're doing that, we're using a calculator. And it's good if we know how to do this without a calculator. It's just kind of some number sense that we're simplifying. So we got 7 squared. The answer is 49. Okay, we bring in a negative. 64 to the negative 2/3. What do I do when I have a negative? Okay, so I'm going to take the reciprocal, 1 over 64 to the 2/3. And I'm still going to simplify the same way. Really, the negative, we move it, that's gone, and I just need to simplify 64 to the 2/3. Whatever that ends up, it's our denominator, and I'll have my result. So it's kind of one step at a time. So it's going to be 1 over, we'll do the cube root of 64 squared. Cube root of 64, that's 4, and then 4 squared. So that comes out to be 1/16. Now, I threw in 2 negatives. I'll move it down. I'll make it 1 over negative 64 to the 2/3. Now, is it going to be even or not even? Positive because it's a 2, or is it going to stay negative because of the 3? Let's do this. Let's go. Can I make it... If I did that, let me make space here. All right, so I have this, or could do the cube root of negative 64, and that is squared. All right, so if we went squaring it first, would make it positive, right? Then we take the cube root, we get a result, it comes out to be positive. Over here, taking the cube root, what times itself 3 times? What to the 3rd is negative 64? Negative 4, right? Because if we have an odd number, and an odd power, and we have a negative, it still stays as the negative, because we had an odd number, negative times a negative, negative. So that's going to be a negative 4. Squared is going to be 16. So that's going to be 1/16. So if you go that method and you look at the cube root of a negative, we get 1/16. Now if you went to the other one, right here, and you squared it, can someone help us? 64 squared? Calculator? Okay, and then we would imagine that now, well, of course it's positive. Now the cube root of that should be 1 over 16. It doesn't matter so much which order you go. I could make it a larger number by doing the power, then doing the root. You'll get to the same result. I would just recommend looking at the roots first. We're a little shaky on some of these simplifying the radicals, looking at the roots. I would do it when it's a smaller number than when it's a bigger. You can do an exponent, you can make it larger afterwards, but it's a lot easier to look at that first. So, those are the numbers by themselves. Let's go look at bringing some variables in. Now we're going to distribute the exponent like we talked about before. And so in the first one, I have 16 to the 3 over 2 times x, or times x to the squared times 3 over 2. Now, we'll take a look at 16 in a second. When I look at that x squared, you had a problem on the homework like this last night. It was it 4/7 and 7?
Yeah.
Okay. It's multiplying fractions. Whenever you multiply fractions, you multiply straight across. Or if you multiply a fraction by its denominator, it just leaves you the numerator. So 2 times 3/2 just comes out to be 3. On your homework, it should have came out to be 4. Because it was 7 times 4/7. Comes out to be 4. So this is going to be a x to the third. Now 16 to the 3 over 2. What root am I going to take of 16? Square root, third root. Which one? Square root. So that's going to be 4. And then 4 to the third. 64. So it's 64 x to the third. Now, if you wanted to write out the step and go you could write it there and then get to that. But as long as you're getting that 64x to the third, that's the important part. Understanding to simplify those radicals. So I'll distribute out up here. You guys finish up. Looks like most got the first one. So 625 to the 3/4 is going to be the fourth root of 625 to the third. I want to cube it. I want to take the fourth root first. What is the fourth root of 625? Perfect. That's 5. So you can just take that out, make that a 5, which then becomes 125. Okay? So that's taken care of. Now, I don't know if you see this pattern, but whenever you have a fractional exponent, when the numerator and the denominator are 1 apart, it's almost like you're going another power up or down. So like here, I had 16 to the 3/2. 4 was the answer. I went up 1 more to get to 64. 16 times 4 gave me 64. 625. 5 was the root it was looking at. I went 1 less because I was at 5 to the 4th was 625. 125 was to the 3rd. So it kind of stays close. Now, that's not something that we recognize like, oh, we'll know 625 and we jump down a power. But what would be good is it just kind of gives you that hint of where the what that root is that you want to find, what that base is. 2 being, or 4 being the first one, 5 being this one. Now, x to the 6 times 3/4. What exponent do we get there? Okay, 9 over 2. You could get 18 over 4, but we reduce that, 9 over 2. You do not need to write that as the square root of x to the 9th. Easier just to write in exponential form. And then what happens to y? Okay, y to the 3rd simplifies out. Now next one. I picked this one for a reason. How many tried to find 24 to the 2/3? How'd that go? Do we have a cube root of 24? No. And then we look at 3 to the 2/3. Do we have a cube root of 3 that's nice? No, it's not 1. No. But what do we know about 24 and 3? Yeah, it reduces to 8. We reduce the fraction. If you come across some of them where it doesn't immediately have a root, look to reduce the fraction. So in this case, it's actually 8, a to the 4th, b to the 3rd, to the 2/3. Now we got 8 to the 2/3, a to the 4 times 2/3, and b to the 3 times 2/3. Going to be a little bit nicer. So what is 8 to the 2/3 going to give us? Cube root of 8 squared. Get 2, square it, you get 4. Perfect. All right. And then 4 times 2/3 for A. 8/3. Leave it as a fraction. Perfectly fine. And B. Yep, just squared. We check, we reduced, positive exponents all around, we're good, that's your answer. Okay, but the key thing is looking for that reducing the 24/3. Along the ways, will you eventually get something that may not simplify? Yeah, probably. But most of the time as we start out, they're going to reduce if they immediately don't have a root that works. Now, last part is we're still going to look at fractional exponents. We're going to change the change what we're solving here. So I have 2 equations there, and we need to solve for x. Now, this is a specific type of problem that comes along. It's solving an equation, but all we want to work with is the exponents. Now, in order to do this, they all have to have the same base. Do they all have the same base? Good. So, we're going to change them all to exponential form. So in our first one, I have 7 to the 5/6. I have 7 to the 3/6 equals 7 to the x over 6. Now I could reduce the 3/6. I'm going to leave that there for a minute. So they all have the same bases. We have the property that says if they have the same bases and we're multiplying, we add the exponents. So I could make this left-hand side 7 to the 5/6 plus 3/6 equals 7 to the x over 6. So, what's x? 5/6 plus 3/6 is 8/6, so x just turns out to be 8. We actually don't use the 7 at all. We're not simplifying, we're not trying to find roots. This type of problem is just saying, can you get them to exponential form? And then use the properties that we have with exponents. So really, it's like we almost circle the exponents and rewrite it to a new equation. It's 5/6 plus 3/6 equals x over 6. And our answer is x equals 8. And we can take this and we can manipulate them and look really ugly with weird roots and bases and stuff, but it comes down to, do you know the rules to set it up? Get it to exponential, follow the rules we've talked about. So, next one. I'm going to write the left-hand side as what? We'll start it. 3 to the 5 over 2. Let's do this. Times. Is that correct? I'll rephrase that. That's not correct. What's wrong with that? This is 7 over 2, right? But it was in the denominator. I moved it up. What happens to it? Now it's negative. Okay. And that equals 3 to the x over 2. We'll reverse the order. If I started with this, and I wanted to make the exponent positive, I'd move it underneath. So I set it underneath, and I moved it up. It made it negative. Because our rule, when it's written here, would be 5 over 2 minus 7 over 2 equals 3 to the x over 2. Because really we're adding the two exponents. So I should put a plus in between. to solve. Now, that moves it up. It turns into addition like the one we just had. Let's leave it as a fraction. Option 2. We'll go far away from the first one. So we got 3 to the 5 over 2, 3 to the 7 over 2 equals 3 to the x over 2. And all I did there, change them all to exponential. Yesterday we said if you have a fraction, you subtract the exponents. Right? That was one of our rules. So it's going to be 5 over 2 minus 7 over 2. And it's 3 to the x over 2. So I could have on the left moved it up. What I did here is moved it up and made it into an addition problem where 1 is negative. Over here I moved it up and just made it into a subtraction problem. It's the same thing. You have addition with a negative or you have subtraction. It works the same. So in either case, it's really saying 5 over 2 minus 7 over 2 equals x over 2. What do we get for x? Yep, negative 2. It's not asking you to write the whole exponent. It's not asking you to simplify. Don't plug it back in. Just use those rules to set it up.
So if you're adding fractions, you subtract the exponents? Why are you subtracting the exponents?
In division, we subtract. In the first one, like up here, I added the exponents because it was multiplication. All I did down here is I moved that up to basically moved it up next to it, and moving it made it a negative, so then I would have added the exponents. It's really if you want to add with a negative or you want to subtract, whichever way you want to look at it. They did not. If it was something like bases of 3 and 7, it's not going to work. But if they were related in some way, what are the homework problems do they have? Different? Perfect. We're going to go over 29. It's your freebie. Let's get a new screen. Thanks. All right. Change it all to exponential. I have 4 to the 9 over 4, 4 to the 1/4, and 2 to the x. Now, they're not like bases, but do you agree that at least 4 and 2 are related? Right? 2 squared to the square root of 4. So we need to manipulate it so that we have the same bases. What I'm going to do first, before I figure out if I want to make everything bases of 2 or bases of 4, is I'm going to combine the left-hand side. So together, it's going to be 4 to the what? 10 over 4? Okay, we add them, 10 over 4. And that actually becomes 5 over 2, right? They're not like bases, but we have to get them to match. So, let's change the 4 to have a base of 2. Do we all agree that 4 is 2 squared? Okay. So instead of writing 4, I'm going to write 2 squared. So in doing that, it's now 2 squared to the 5 over 2. Which makes it 2 to the what? So what's x? Comes out to be 5. So we simplify it down so we just have equals, one term on each side, and then you can manipulate it to fit what you want, get like bases. Now that's only going to work if they're related. If they gave me different powers of 2, I could work with those to get to it. If they're relatively prime to each other, 3 and 7, 3 and 5, It's not happening. Now, if I went back to this and said, all right, well, I want to make both have a base of 4. Maybe the situation just fits better than that. Well, 2 is 4 to the what power? Yeah, it's the square root, so 1/2. Which makes this 4 to the x over 2, or 4 to the 5 over 2. Did we get the same result? Yeah, still x equals 5.